Bismillahirrahmanirrahim. Assalamualaikum. So I would like to go to subtopic 7.6.4 steps in the identification of the Box-Jenkins model. There are four procedures in order to identify the ARIMA model. Number one, we need to construct a time series plot for the original data. Okay. The purpose is to identify any unusual observations if exist. So we need to decide whether we need to use the transformation technique. Okay, and student must be remembered to also plot the ACF and PACF in order to confirm the stationarity condition. If data series appears not stationary, so we need to perform the first difference. Okay, the first difference. For the non-seasonal data series, okay, the first difference is sufficient. If seasonality exists, perform the seasonal difference. Okay. Alright. So when stationarity condition is achieved, so we can identify the ARMA or ARMA model by looking at the ACF and PACF plot. The model identification stage, it might be slightly easier to select pure AR and pure MA models. But when selecting a mixed ARIMA model, the process to decide on the values of P and Q is much more difficult. It is worth considering several possible models in order to minimize the chance of not picking the most appropriate model form. To finally determine the best fitted model, so we can use several statistical measures such as MSE, AIC or BIC, or we can also use the box-Pierce-L-Young box statistic. Okay, now the final notes on identifying the theoretical model. So number one, if the autocorrelation function ACF decays exponentially, and the partial autocorrelation function PACF has spikes, so the process can best be captured by AR model. So sekiranya kita melihat kepada ACF plot, sekiranya berlakunya decay, penurunan secara perlahan, dan terdapatnya PACF mempunyai spike, so the best adalah AR model. Okay, so in this case, the order of AR model can be determined by the number of significant spike in PACF. So in order to get the AR model, how many P, how many parameter, so we can look at the significant spike in the PACF. If the partial autocorrelation function PACF decays and the ACF has spikes, the process can best be captured by MA model. The order of the MA models, the number of Q equals the number of significant spikes in the ACF. So in order to find how many theta in MA model, so we can look at the ACF plot. If both the autocorrelation and the partial autocorrelation function ACF and PACF are characterized by irregular patterns, so the process can best be captured by ARMA model. So ini merupakan serba sedikit tata cara untuk kita mengenal pasti berapakah bilangan P dan Q dengan merujuk kepada ACF dan PACF. So in short, in order to get the number of P, how many AR parameter that we need to use, so we can look at the PACF. Meanwhile, in order to get how many theta, how many Q in order in the model, so we can look at the ACF plot.